Hello and welcome to the UMUC Statistics 200 Week 2 video. I'm putting these videos together on a weekly basis to cover some important topics to help support your homework and tests. So first, we're going to cover two topics this week. One is frequency tables, the other is box and whisker plots. For a frequency table, I'm going to show you how to fill in a table, how to make a histogram, and what is the skew of that distribution. And for box and whisker plots, we'll look at quartiles, the interquartile range, and where is the median. So first we'll look at an example here of a frequency table. And this is some data that's given in a frequency table where we have some empty table values. And we have to figure out how to fill those in. The first thing we'll look at is the frequency, and that is the number of samples that occur for each of these intervals. And you'll notice we have a few missing. So to work backwards, we have to go with the data we have. The relative frequency is the percentage of total samples that are within that range. So in this case, if I'm looking at 45% is the relative frequency for this range of 20 to 29, it's 45% of 20. And if you take 45% of 20, you will get 9. So 9 must be the frequency that goes in the interval 2. And then by process of elimination, we know that 3 plus 9 plus the interval 3 plus 4 must equal 20, and we can fill in the rest of the table. So let's see what that table looks like when we fill it in, and I'll scroll down. So here's the table filled in and the distribution in a histogram form. So remember, I was just talking about relative frequency, 45%. So that gives me a frequency of 9. There's 9 samples in this range. To get the sum total to 20, this number must be a 4 in the third interval. And then we can fill in the rest. The relative frequency, again, is a percentage. So if I want to find the relative frequency of interval 1, I take 3 divided by 20, and I get 0.15, or 15% of the samples are in that interval. The cumulative frequency, I add up the relative frequencies in a cumulative way. So I start out with 0.15, then I add in this value, 0.45, that gives me 0.6. I then add in 0.2, that gives me 0.8, and in the end, this number should always be 1 at the end of the cumulative frequency. Same goes true for relative frequency. These numbers should always add up to 1 because that says we now have 100% of the data. Now let's look at the histogram. In the histogram, this is the plot. This can be done in Excel. There's a variety of programs online that allow you to do this. So let's look at some questions about analyzing this data. The first one is, what is the percent of people with times 30 to 39 seconds? Well, if I go to this interval 30 to 39 seconds, there are a total number of samples of 4, but the relative frequency shows us the percent. So 0.2 is the same as 0.20, or 20%. So 20% of the people have times of 30 to 39 seconds. How about the percent of people with times above 30 seconds? So anything above 30 seconds means I have to consider intervals 3 and interval 4. So one way to do that is to add up the relative frequencies of those two intervals. So if I add up 0.2 and 0.2, I get 0.4, or 40%. So there's 40% of the people with times above 30 seconds. So now let's talk about what interval is the median. The median, remember, is the middle of the number of samples. So if I have a total of 20 samples, the median must be between 10 and 11. In this particular case, you have to find the average of 10 and 11, so it's actually 10 and a half is the median, puts you right in the middle. Or it's exactly 10. I take that back. It's exactly 10. So in this particular case, if I look at the data, I see that there are 12 values in the first two intervals and then 8 in the second. And since we know the median falls in the 10th sample is the median, in this particular case, that 10th sample must fall in the second interval. And that's the answer. And finally, let's look at positive or negative skew distributions. If we have a positive skew, we are looking for a hump on the left side of the sample set, and the tail will go to the right. And for a negative skew, we're going to have a hump on the right or the tail on the left. In this case, the hump is on the left-hand side of the middle, so we would say this is a positive skew. And typically it'll be pretty obvious. There'll be a whole bunch of data on one side or a whole bunch of data on the other side to make it positive or negative. Let's move on to the next topic, box and whisker plots. In this case, I'm given a set of statistics for points scored in a football game in a season. There's two teams here. And the data you're given is the low, the Q1, which is the quartile 1, the median, which is right in the middle, Q3, quartile 3, and the high. And what I've done is I've taken the data in this table and I've plotted it in a box and whisker plot on the right-hand side that you see here. And this box and whisker plot shows us all of those data values. So you see in Team 1, you see the low, the Q1, the median, the Q3, and the high. And what we normally do is we create a box between Q1 and Q3, and sometimes you shade that in if you want, and then the median is the middle line. Notice how it looks on Team 2. On Team 2, the distribution is wider, so you've got more data values from low to high, and you've got a middle range. We call this the interquartile range. This middle range is also a little broader. So what is the interquartile range? The way you find the interquartile range is we take Q3 minus Q1. It's basically the number of values, or the number, not of the values, but the actual values themselves. The difference between Q3 and Q1 is the interquartile range. How big is this box? So for Team 1, I would take 40 minus 20, and my interquartile range will be 20. So what is the percent of data in each quartile? By definition, a quartile means 25%. So let's go back and look at this plot again. 25% of my data occurs here between the low and the Q1. 25% of my data occurs here. 25% here and 25% here. What you don't know in the data in the top in the top figure, the table that's given, you don't know how many scores there were in the season. All you know is the values of this range, but you don't know, were there 20 games played, 10 games, or 50 games? We don't know. But we know that 25% of the games are here, 25% here, and so forth. So now let's look at some interesting questions. Which team has the greatest percent of scores under 20? So think about the quartile range. If I look at Team 1, it has a quartile 1 of 20. That basically tells me that under 20, there's 25% of all my scores are under 20. But for Team 2, the quartile 1 starts at 17, which means the value of 20 is somewhere in between quartile 1 and the median. So therefore, there must be more scores for Team 2 between 20 and less. Now let's look at the next one, the greatest percent of scores above 40. If we go to this one, we notice there's a quartile range here for Team 1 at 40. 25% of all of its scores are above 40. But for Team 2, 25% of its scores are above 42. The 40 falls between the median and the Q3. So therefore, there's likely more scores down here between 40 and the high range. So again, Team 2 will have more scores above 40 because 40 falls between the median and Q3. And then finally, what is the mean score, the average score for Team 1? Important about this question is we do not know what the actual data values are. There's not enough information to find this answer. The box and whisker plot only gives us the distribution of the values and not the actual values. So we know where the median is. The median is, if I have 50 samples, the median will be in the middle there at the 25 location, right? It'll be the middle the middle number of samples. But I don't know what the mean is or the average because I don't know the actual values. I would need to know every score and then I would take the average, and that's how I find it. So I hope this video was helpful, and I hope this helps you out for your week 2 homework. Thanks and have a good day.